Okay. Good afternoon, everyone. Welcome to the January 2021 edition. Actually, it's January 21st, 2021. What an opportune date to begin the first VLab Forum for the year 2021. We kicked off this series back in 2009, so this is our 12th year. How time flies, of sharing R2O projects that are relevant to the National Weather Service, those that are way upstream from operations and those that are closer in hand, and an effort to inform National Weather Service field and other entities about these capabilities so that we may better prepare to implement them and use them once they're implemented. So today, we're very fortunate to have Dana Strom, who's going to be our speaker, presenting a topic which is about the what's up with the what's up, or the whole story uncertainties and probabilities viewer. And a lot of you are actively using this tool and have been providing lots of useful feedback through the VLab community for what's up, and using this to hopefully understand and better exploit the probabilistic information that's available for the purposes of IDSS or other things as we move to a more solidly grounded foundation of probabilistic information in the National Weather Service. This project is also very topical in the sense that the viewer itself is being hosted in the Amazon Web Services in the public cloud, and you all are using it in that host. So we're interested in sharing the latest that Dana and the crew there, Dave Ruth, David Millard, Kevin McGrath, and Tim Kempesty have been working on, so that you can see it and try it out for yourselves, take it for a test drive, and provide even more feedback on making it better to serve your needs. So without further ado, I'm going to hand it over to Dana to take it away.
Thanks a lot, Steve. Yeah, again, thank you to the team for all their hard work. I wouldn't be able to present anything without them, so thanks to them. This is meant to be kind of the next iteration of the What's Up presentation. I did another VLab Forum back in September of 19, and at that point we were still the ensemble viewer and the NBM forecast viewer. But we have since merged them into the whole story uncertainty and probability viewer. This is meant to be a kind of state of, the current status of what we're working on, what we have coming in the future. And we've got some really exciting stuff that has come together faster than I anticipated. So it wasn't in the original announcement, but we've got some really good stuff to show. So without further ado, what does What's Up have now? We have NBM 4.0. We will have the experimental version when that gets up and running for all the domains. We also have the GEFS bias corrected forecast products in there now. We have NBM component visualization for quite a few elements, and GEFS point visualization for temperature and some for surface and upper levels, relative humidity and precip. We also have added a second slider for dprog DT mode and the categories in the plan view. We've added dprog DT mode in the point visualization, as well as added some optional wind barbs and contours. So I'm just going to jump over to the interface and just show those. So this is the default load of the What's Up viewer. You have, of course, your forecast slider on the left and your second slider just to the right of that, which in this is dprog DT. So you can, of course, use your right arrows and left arrows to go back and forth in forecast time. and your dprog dt, you can click on the circles, or you can use the down arrow and up arrow to see how the forecast has adjusted over time, how it has been trending. Now, if we pull up a probabilistic element, so we can say pull up QPF06. Let's pull up. So it on default loads, of course, all your forecast projections, and the second slider is now your probabilities. So if we go forward in time, we'll be able to see default is the 50th percentile. You can tell that by the black circle. I'll explain more about that in a minute. You can, of course, go through with the forecast projections, see where the 50th percentile is, saying there might be some precip. And as we get towards Monday, it looks like there are two areas of larger precip that might be more interesting to look at. So you say, okay, well, for let's go to 12Z, for example. So right now we have the 50%. The 50 percentile selected here, and we can go, say, to the 25th percentile, load that, then use our down arrow, up arrow to go to 75th percentile or the 90th percentile. And then we say, you know, I'm really liking the way that the 90th percentile looks. I want to load all of that and see that a little bit more. So if you hover over for just a second, you'll notice this pop up. Just a little tooltip to remind you that if you double click on the circle, it will load all of the forecast projections for that threshold, not threshold, that percentile. So now all your forecasts, if you use the left and right arrow, will be on the 90th percentile. Just makes it a little easier to navigate back and forth between temporal space and categorical space, or percentile space. So you can say, okay, well, on this valid time, let's go back to Monday. So Monday at 12Z, we can say, okay, well, how has this forecast evolved over time? So we have a dprog dt button here. So if you click that, what'll happen is it will load the forecasts back in time for this valid time. So this was the 12-hour previous cycle for this valid time. And so now we're in dprog dt mode, where we can see how this forecast has evolved leading up to this valid time for the 90th percentile. So you can do this for any of the percentiles that you're interested in, and you can go in and out of dprog dt mode, back to percentile space, and load up whichever percentile you think is most representative of the case, just to get a little bit more into it. So that's dprog dt mode in percentile space. We also added dprog dt mode in the point visualization. So I'm actually going to zoom in because I'm somewhat interested. A case was brought to my attention that we actually fixed this morning, but I'm going to bring up there in the mountains of California. There's looking to be like there's some snow in the Monday to Tuesday timeframe, and I kind of want to use that as an example here. So just to review what I just did, you can click on the map at any point, and it'll get the nearest neighbor station, and you can pull up the component point visualization, and then clicking on that will bring that into a new tab, and you can see the point visualization from there. So this is the latest. Well, this was the 12Z run, since I had that. It was selected over there since I was on PQPF. So here we have the 12Z point visualization. So I have selected by default, maximum temperature gets selected, as well as our winds. And so we can see in this top graph, we have the components that went into the blend for this run and what they all look like going out in time. Now, we have a few hovering techniques that I just wanted to point out. Actually, I want to jump back really quickly to the slides. So there are a few more techniques in the dprog dt that I wanted to jump into just a minute. So we have new hovering techniques. I want to go into a little bit more utilizing the windrows and the violin plots. Then I want to go into dprog DT mode and then talk about the new quantiles for MBM that we added in for the QMD products. So I'm going back to the user interface. We have the ability to hover over. So right now, when it defaults load, you can hover over one of the points and the rest of that line, so that component will show up highlighted, which is pretty useful if you wanted to see exactly what that source is doing. But you can also, up here in the top right, you have another type of chart hover. So this compare data on hover is quite useful as well, where you can say hover over one point and you'll get all of the sources at that valid time and their associated value, and they are well, decreasing from top to bottom. So they're ordered by value. So you can quickly compare what source has what value. So that's another cool tip. Also, what we can do is, since we're on 12Z, at 0Z, 6Z, 12Z, and 18Z, we have available the QMD products. So this is the components. And if you click this button here to pull up the quantiles, you can do that. So this is the max temperature quantiles. So this is the QMD product that MBM puts out. This is the, so you can hover over and see the 90th, the 95th percentiles, all the way down to, of course, the 10th and 5th, the 10th percentile. I thought we had 5th too. One moment. Yeah, it's very small. There must be not so much variation on the bottom side, but we can, of course, switch our hover technique to the compare data on hover over one of the points, and see the distribution between the 5th percent and the 95th percentile of the solutions here. And if you also noticed, so not only did the top graph change, but so did the bottom graph. So the bottom graph also has the QMD values in there, and this is the QMD preset. So you can see the range between the solutions of the 5th percentile to the 95th percentile, and they're in stacked bar here. Also below, I want to just point out the windrows and the violin plot. So the windrows, of course, is it is the winds that went into the max temperature weather element, and you can change the valid time by, of course, using the slider on the bottom. It is drawn via proportionality to the amount of members or components that had that solution. So 50% of the solutions were 0 to 9 knots coming from the northwest. You can see the colors change based on the magnitude of the winds and the percentiles. The length of the bar depends on the number, percentage-wise, the number of components that went in, and also that had that same direction. So 25% of the direction from the west-southwest is 10 to 20 knots. So you can see that change over time. And also changing along with that is the violin plot here on the right. Just a refresher on the violin plot. It gives you a sense of the distribution of the potential solutions. So if they're all clustered around the median, you'll end up seeing a very sharp spike in the violin. If there's less certainty, more distribution in the solutions, you'll see a little flattening of the violin, if you will. So in a more uncertain environment, you'll see a much flatter violin. So you can get a quick sense of whether or not. So let's see if we can find. So this was max temperature. We'll have a few more members in the temperature weather element, and so we'll be able to see the distribution. Also, if you bring up a weather element that has both bias corrected and raw, components. So this was the direct model output data that went into the blend, and then this was after the bias correction. You can see the difference between those as well. So change to the valid time that you are interested in, and you can see the different distributions. And you can then, of course, see what the bias correction has done to the sources. So that's a little bit more about point visualization. Oh, I completely forgot about dprog dt. So say we are interested in this valid time. We can actually, you know what? Let's go a little bit further out. Something a little bit more uncertain. So a little bit more distribution. So you can see that there's a little bit more uncertainty in the a little bit more distribution in the components. So what we can do is say, okay, so at Friday at 12Z, let's do 12Z. Friday at 12Z, we want to see how the forecasts are looking like leading up to this point. So dprog dt mode, the button again is here. You can click that, and what that does is says, okay, how did each of the components do leading up to 12Z? So now what we have in this return is all of the components, all of the previous cycles for those components, and how they changed leading up to that 12Z. So for every cycle that has a 12Z valid time, we have that data point, and we can pull that back, and you can hover over and see how the sources have changed leading up to this valid time. And so you can see if a model has been pretty consistent on a solution, or if it's wavered quite a bit, you'll be able to see that as well. Then if you wanted to, so say you were like, oh, well, 12Z is fine, but I really want to see what 0Z is looking like. You can switch your valid time here. So I'm pulling up Saturday at 0Z for that same point, and you can see the solutions here. And you have your operational blend there, and the other sources, the other components that went into the blend at this valid time, or for this valid time, I should say. And then, of course, you can come out of dprog dt mode and interact as normal, changing your date and your date cycle here on the left, and your component. Of course, you have GEFs as well. We're going back to 6Z since the 12Z data wasn't in there. But then, so if you're looking at GEFs, you'll see all of the member solutions here from that issuance time, from 6Z. But dprog dt works the same way. You can click dprog dt, and now we're doing dprog dt for the GEFs, which was what were all the different members doing leading up to that valid time from the previous cycle times. All right, now I'm going to jump back. So what's up next? So what we're trying to do. There's a lot of research and development happening in the field, and we're really hoping to get to be able to take the best in class visualization that you in the field have come up with, and be able to integrate them into what's up. So a few of those include the likelihood to achieve graphs. Greg Mann, he did a talk not too long ago about those. So we're going to be working with his code to get those into what's up. We're going to be adding more GEFs elements to just supplement the amount of elements that we have for GEFs. We are going to be adding NDFD. So NDFD is going to be a comparative source that we'll be able to plot next to the blend. It'll make it easier to be able to compare how what the NDFD solution has compared to the blend, as well as the weather in context over at WPC. We're going to be integrating that as well. Now, something that I didn't know was going to come together so quickly, but did, and I'm very happy to spend some time talking about it, is what we're working on right now. So we've been working with a couple different partners. So You may or may not be familiar with the MBM1D product, developed by Travis Wilson, Ryan Walsh, and a few others listed here. It's a very fantastic site, and we've liked it very much. And so we worked with them to obtain their code and see if we can replicate that within the WSUP environment. We have also worked with MDL-WIAD, so the Weather Information Application Division. The developers there, Shane Mill, Jason Burke, Steve Olson, to utilize a standardized API called the Environmental Data Retrieval API, the Application Program Interface, which is National Weather Service's standard API. It's envisioned to be a standard API that kind of improves on web coverage service. So web coverage service allows a polygon to be queried, but the EDR API does a lot more than that. It allows for polygons. It allows for quite a bit of different returns in terms of data format, so XML, JSON, etc. But it also allows us to essentially query n-dimensional arrays and add a single lat long. Why is that important? Well, we were able to connect this EDR API, which was developed with a partnership between WIAD and the UK Met Office. We were able to take the EDR API, get a return at a single lat long, and from a backend data store, and attach that to the 1D visualization code. I'm going to go into a little bit more detail of the backend before I show you, but we're really excited because essentially we were able to take the 1D code and apply it to any lat long point and get a return in very decent speeds. So the backend data store, it took the GRIB2 data and we pack it up using X-ray and ZAR into a backend data store. And we did quite a bit of tuning to optimize a query for a single lat long. Essentially what we did was we took the GRIB2 data and X-ray and using X-ray and ZAR, we were able to create 128 by 128 chunks. So what that allows us to do is take the grid geographically and break it down into 128 by 128 pixels and store all the weather elements and all the valid times together in the data set and by that 128 by 128 pixel. What that means is we just have to load less data than if we were to try to look for 1 pixel in the whole grid. We're just looking for 1 pixel inside of this 128 pixel box. So we have to load a lot less data in order to get the results, which means that load time is a lot less. Processing time is far superior than if we were to try to do it on the whole grid. And I will also say that this will be available for all MBM domains, so CONUS and OCONUS alike. Just a little bit more nerddom, space necessities. So it takes so for the 575 gigs of MBM data, raw GRIB data that we have every hour, that we're able to compress that down to about 415 gigs per version per day for the backend data store. We store that data on a Lustre instance, which is it's an SSD that we can cross mount on any of our AWS instances. So it can be available to whatever server we need it to be on, which means that we could horizontal scale and have better performance that way, but without having to duplicate data. So that's very important. The return of the data is very low bandwidth friendly. The return for all of the weather elements comes back and it's less than a megabyte per the return. It's about 915K or something like that. 915 kilobytes for all the weather elements for all the valid times at 1 pixel, or yeah, 1 pixel. And then all of that is done in about 5 seconds. So is it the fastest? No, but is it respectable? Yeah, it's definitely doable. So just to break down a little bit more spatially, because this is how my brain works. So here's the United States. This is a not to scale representation of chunking the data into 128 by 128 pixel chunks. Now, say we want to query just one point. So we say, okay, here's the lat-lon I want. Then we send that lat-lon to the API, and the API says, okay, I know what pixel chunk that's in, or that chunk that's in. Here you go. And so it loads all that data, finds that pixel inside of it, and returns. And inside of this chunk is all of the weather elements. So all of the forecast times for temperature, dew point, wind speed, wind direction, etc. And then that API returns a JSON. So this might look very familiar to a lot of people. This is the 1D viewer, but the difference is this data is connected to our backend data store. So you can click on any grid point that's predefined. We have these laid out here still. So if you wanted to query this specific point, you very well could. But say there was a very specific event you wanted to pay attention to, maybe one by the capital, you could click on that point. It will get the nearest neighbor lat-lon point, and it will pull up the mediagram for all the weather elements for that specific grid point and pull it up. So this has all of the same graphs that the NBM 1D product had and currently has. It has everything, but it is for that specific grid point. So not predefined. You no longer have to say, hey, can you add this specific point in? You just find your place on the map and click. And the API goes in the back, grabs the data at that grid point, at that lat-lon, comes back and plots up all your graphs, and it updates appropriately. So if we come back out, there was a snow event that I mentioned earlier. We come back out and say, okay, how's this mountain range going to do? Well, we don't have any stations listed there, but you can just, I don't know, click on the map. And so it's grabbing the data, coming back, and then we can look at the temperature profile and see how that's shaping up. We could scroll down, look at the precipitation type around, Monday, Tuesday time frame. We can scroll down a little bit more and see what the 6-hour snowfall looks like, snowfall rates and totals. The blend is calling for 25 inches over the next forecast period. And you have every weather element at your disposal here. So yeah, so this is what we're really excited about. It's very close to being available. We have to figure out how we're going to implement it in production with in Amazon Web Services production environment, I should say, and how we're going to horizontal scale things like that, because of course we want to make the product available and not slow for all the users who may want to use it. So with that, I think that just about wraps it up, and I look forward to hearing your questions. So.
Okay, Dana, of the Meteorological Development Laboratory, which I failed to mention at the outset, thank you for that summary and demos. And at this point, we're going to open it up for question and answers for Dana. So if you would like to ask a question, you can use the raise your hand feature in the GoToWebinar, and John Chattel will unmute you and you can ask your question, or you can type it in the chat box. And then we will, and actually Dana can read it for himself and answer it because he can see it. So Yeah, this is fantastic. I think, you know, it's obviously some of the topic, it touches on so many issues that we've been discussing for months and years now, which is that there's just um, so much coming out of the blend and the ensembles, and you know, how do you scratch the surface? How do you dig down in an efficient way to get useful information? These are huge challenges. You know, we're approaching these challenges through smart visualization, you could say, tried and true, and with feedback from users on what is useful. And that is really a primary focus of today, is to hear from you all, and get some sense of how this is working, or what you might like to see, or, you know, just general questions. It does lend itself to the idea that the sort of data analytics AI is definitely something that we want to apply as another methodology to kind of extract information out of this huge volume of probabilistic forecasts. So you know, the thing that's the thing that I mean, I'm curious your thoughts, Dana, on the topic, is that you know, there's just so much. Even here, this is well organized, and you know, but even then, it strikes as being a kind of a potential fire hose. And then how do you know, you personally have, obviously, in developing this, come up with things that you find useful. Is there just, it's really based on individual users to sort of determine what is useful for them in interpreting the data, and so of all the potential things you can look at, you know, you end up looking at just a handful of you know, critical visualizations to get yourself situationally aware?
Sure. I mean, caveat, I'm not an operational forecaster. But with that being said, you know, of course, there's an astronomical amount of data here. You know, we have, what is it, 3 million grid points, you know, for just one weather element that you can look at. Obviously, you're not going to pay attention to that, but you might be interested in, you know, the difference between, you know, the gradient of the mountain, you know, the mountain range. So there's just, as you said, there's just so much information to pay attention to. Thankfully, the 1D developers, they were able to at least limit the weather elements that you can select. So if you wanted to, you can also create your own custom. So if you only want to pay attention to a few weather elements, you can select just the ones that you're interested in, which is nice. It's a nice limiting feature that definitely helps. You know, if say you only care about freezing precipitation, you can look at, you know, the temperature field and the freezing rain and the p-type, things like that, and be able to at least limit the focus. I think obviously it's very dependent on the situation you're in, you know, the regime that the forecaster's in, or what the user's paying attention to. It's all very dependent on how to limit data. But yeah, there's just so much data that we're just really hoping that we're able to come up with some more smart ways, or partner with people who have really great ideas to help digest all this data. We are very thankful to have the partners in the field that we do. And we're always welcome to hear from more forecasters or SUs, et cetera, if anyone has any ideas on ways to make the data visualized even better.
Right. So I'm again curious whether you've heard it through the forecaster user base, or from or elsewhere. This custom feature would seem to lend itself to have custom displays for specific core partners, you know, like state Department of Transportation, you know, this, you know, so based on their decision points, certain visualizations may lend themselves better to that. And, you know, you mentioned Greg Mann's work. for airports in Michigan, for example. So that seems like an area ripe for exploitation using this kind of tools to set up visualizations per the IDSS partner that you or class of partners that you work with.
Sure. Yeah, and we've definitely thought, so we've been doing some brainstorming too, and how we can utilize the EDR API, which essentially just, if you think about it as you give it a lat long, it gives you back the data. You can do so much with it. It's not just limited to this one application. You could, we've thought about creating a dashboard per se. So you could say, that you can have the elements that you want up all the time. It auto refreshes whenever something new comes in, you got it. And so you could just have it up there for a situational awareness, however you'd like, or however in which manner you'd like. So yeah, we've definitely thought about that. Our first goal, of course, was to get this up and running, but now, the creativity is what is the fun part, and that's next.
Okay, John, do we have any hands raised or questions for
Yes,
Dana?
absolutely. I think Bill Roche would like to chime in on your question. Let me see if I can unmute him.
Hey, Bill.
Go ahead, Bill. Are you there, Bill?
Hey, can you hear me?
Yes.
Yeah.
Cool. Hey, thanks, guys. Steve, you were kind of asking, feedback and stuff like that. Travis and Ryan were the main developers of this, and I just helped them out a little bit. But our feedback came straight from the forecasters, and I can just give you a couple examples. I don't know if you have it working, Dana. The custom threshold button, that little arrow to the right of the one that's green. Does that one work at all? Right next to the settings button to the right. Keep going. That one. Does that work on your system? That is, yeah.
Oh, this downloads this is the CSV download.
Oh, I'm sorry. The other. Oh, that one there.
This
Sorry.
one. Yes, I believe it does.
Yeah.
So
this is what really people are liking is you can, you think about your different partners and different thresholds that are important to them. And so if it were working right, it doesn't look like it is. You can,
we're just getting it up.
Yeah, right. And I'm sorry, but it's a great example, Steve. Once they get that working, it works on the operational one. So you can slide in like, like Western Region just highlighted it for the system coming in here. And what's the probability of exceeding an inch of rain at a certain spot over 24 hours? And, it just looks at the NBM data, pops that out and plots it out really simply to see what your, chances of exceeding whatever threshold you're important in. You can do it for temperatures too, which are for, at least in my office, one of the things, Dana, we're still trying to do, I don't know when we'll hand it over officially, but get like record highs and record lows in there so that you could just hit one button and generate the probability of getting record highs or record lows. Also for fire weather, probabilities of RHs and wind speeds hitting certain values. So the IMETs that are out in the field can literally generate true probabilistic information, not just pulling it out of the air. It's true probabilistic information that they can tell people on the fire that, hey, there's a 40% chance of us hitting this criteria with this system coming in and things like that. So the other one, if you go back to the main screen, is Travis ended up plotting the deterministic value on the box and whiskers there. Because it's interesting to see where the deterministic falls in the range of it, especially the QPF. It's been interesting to see that the QPF often falls in the higher percentiles of it and stuff like that. So some of it's just, the feedback has been just to get the forecasters used to looking at the NBM data and getting used to it. But some of it's been really tied to, IDSS, people in the field and how they really want to use it in the field.
Thanks, Bill. So yeah, you just touched upon kind of like dual purposes and where we're at in the Weather Service is educational familiarization with the NBM and probabilistic data, as well as growing need for IDSS support. So, I mean, it seems like a linkage, if you will, to what has been previously called an impacts catalog is sort of a natural for this, in that if you develop visualizations that are keyed off of thresholds and you can generate those or even notify, I guess,
Right.
that you're starting to cook with gas. Am I getting that right?
Yeah, exactly. And then the operational version, those images you're looking at right now, Dana, are there. You can save the URL. So in theory, if it were visible to a customer, they could just have that URL and pull it in and pop it up. Or the forecasters can make quick links for all, special sites, maybe at the Super Bowl or something, and they want to quickly brief themselves. They're quick links and you can pull it up anytime. But yeah, that whole concept of tying it back to something like you said it makes sense. And I see, Danny, you have it working now. So
Yeah, so we just started. There are a few weather elements that are working. There are some that are not currently working. But yeah, I mean, I may or may not have said it, but we literally just got this up in the last couple of weeks, working with our lat lawn return and all that. So yeah, we still have to go through and make sure that everything's going. But
well,
yeah,
I just wanted to say, Steve, and for me, the partnership that we did here with you guys, I think it's amazing. It's fantastic, and I hope there can be more projects like this where, literally Sue's in the field who are working directly with the forecasters, and now working with MDL and Dana and their folks. I hope there's more and more like this, because it's fantastic. And the fact that you guys got the points working now anywhere, that's huge. So this is a really cool project. It was a really fun one to work on. And again, Travis and Ryan's on the call. They did all the heavy lifting. So I'm just babbling on here.
Yeah, no, I really appreciate your sentiments and sharing those, Bill. I'm feeling the same thing, and we got example of bringing together the right diversity of players to turn out a really powerful product. I'm very happy to see the application of some of the stuff that Steve Olson and company have been using to being brought to bear on this for the pick your point kind of thing, because that's a huge deal, actually, to efficiently extract data out of a massive volume like we're generating every single hour. Thanks again, John. I see Tim Barker has got his question mark. It's no longer a hand, it's a question mark. Huh.
There are hands as well. For example, Jim Siebeking has his hand raised. Would you like me to unmute him so he can ask his question?
Sure.
All right, go ahead, Jim.
Hey, I just wanted to say, first off, thank you for all the work on this. I think this is probably the single most important project the Weather Service has going on right now from an operational standpoint. Is there any future plans on trying to make like mediograms and stuff like we see on Weather Bell and weather models, those pages where you can see the actual values for all the GEFS or the EPS members? I look at, like, on the WSUP viewer, and I look at QPF, for example, and it seems like there's maybe 3 or 4 members that show up when you do the forecast fields.
sure. You're talking for blend specifically?
Well, like, I think of, if we're going to do complete uncertainty and we're going to talk about everything, I know the NBM has a list of components in it, but from a forecaster standpoint, they want to see the full range of solutions. And so, especially in the extended, if we can see in one place the GEFS, the EPS, and the Canadian ensemble, and then see maybe where the NBM falls within that for whatever element. That it would just, if we just need a one-stop shop, because right now I'm telling forecasters, go look at Weather Bell, to look at the European ensembles, go here to look at the GEFS, go here to look at the Canadian. If we just had a one-stop shop, and I think your project is it, that would be fantastic. But great work, and thank you.
Yeah, thanks for the feedback. Definitely appreciate it for sure.
All righty, thanks, Jim. Next, John, who's up?
We have Paul Inouez would like to ask a question, and let me unmute him real quickly. Hold on just one second. There we go. Oh, pardon the delay. Okay, there we go. So Paul, you should be able to talk now. Go ahead.
Hey guys, really been a big proponent and user of this tool. We're getting a lot of use in my office and as well. One of the questions I had, I like the API development aspect of this. So what is there going to be additional information that's not seen here? Because I know one thing for like DSS purposes is getting the full percentiles out of some of the metrics, like the PQPF and the max-T and min-T percentiles. Because that's stuff that if we could start automating some graphics, you know, for the offices at our local level to be using, because that's I think our next real big challenge is how do we take this information and turn around and effectively communicate it to customers. So an API could certainly help automate that process for our staffs.
Sure. Yeah, no, and that comes back to the dashboard idea that we had tossed around a little bit. I feel like that could, I feel like there's definitely something we could, you know, without too much effort, put together to create some sort of dashboard or API in order to get your, you know, even if you had access to the data and you could provide it in whichever form you see best, or we could partners could create some sort of dashboard that would work for you and your partners. I mean, I feel like that is a direction that we should definitely go.
I know, maybe I could send you some example after this too. It's I've been able to access some of the like PQPF data, and like Bill was mentioning, plotting the deterministic against where like a cumulative plot of the percentiles, and just seeing that it's often landing right around 75th, 90th percentile. But it really helps communicate even to the forecasters seeing some of these different structures, what the NBM is actually forecasting, and can help us in our messaging.
Sure. Yeah. So just a quick point. We also have the percentiles in the accumulated for gifts, which is a start.
Yeah, I mean, Paul's question kind of was one I was thinking about in a different sense, but essentially is the translation of you could say our meteorological nerdy, geeky, wonky, whatever you want to call it, view of the world to a core partner who doesn't have the expertise. So I'm not. I think you know, Bill's the wave and the 1D have aspects of that, but you know, for some core partners, these types of displays are probably fine, but I'm kind of feeling that for a lot of them it's too complicated. So that translation, I guess, to actionable graphics, maybe that's the term. I presume that's being done by a variety of ways across the Weather Service at the moment. There's no standard way of doing that, whether it's the weather story or some other graphics package. I'd be curious to hear anybody's comments on that. You know, is that a downstream thing that should be separate from, you know, this kind of viewer, or do they need to be intrinsically linked? Any thoughts on that from anyone?
Just my two thoughts. So right now the API is it's not hidden, but it's hidden behind authentication. So right now, and in order to save the machines and not grossly overrun costs. We needed to keep behind and have it really only be connected via the WSUP at the moment through password auth. Now, that's not to say that it has to be that way, but since it's living on AWS and we pay for outbound costs and processing time and server time, et cetera, that's the current implementation. But of course, that's not necessarily how it needs to be if there were other directives. But to your question, does it need to live in this application, or should it be you know, done by someone else or somewhere downstream? I'm not sure. I have no idea.
Yeah, well,
Obviously,
thanks.
Obviously, we know the data, but JSON's so easy and ubiquitous, and you know, it's very standard. So it's not like we're doing anything proprietary here.
All right, John, other questions from the audience?
Yes, Dave Ruth would like to ask, could you say something about how zoom levels work with contours, sample points, and wind barbs?
Oh, sure, Dave. Whoops, wrong browser. Thanks, Dave. So let's just quickly go back to our plan view. So our plan view, we have our map here, which is still showing PQPF 90th percentile. So in this menu on the right, we can pull out, and we have two options for additional information. So we have our contours, which you can turn on, and it's not going to plot anything. And the reason why it's not, all right, found a quick bug. Sorry, no, it will plot here. So the difference, I got confused, sorry. So this black area, here says, I don't want contours to be drawn in this, at this zoom level. And then the white area says, yeah, the contours are fine. So if we move our slider over to the left, it's going to not plot until we zoom in, just because the contours can be pretty noisy that high up, depending on which weather element. So once you zoom into this level, then your contours appear. So you know, if you really want more of a detailed picture of it, but when you zoom out, you don't want them to load and to slow down the interface. That's why we have this zoom level the reveal on zoom level. Now the same thing can be said for the wind barbs. So let's, for the time being, turn contours off. Let's go to temperature, since we have wind barbs activated for hourly elements. So once this loads, we'll be able to click this checkbox here to bring on the wind barbs. Perfect. Now, the reason why they didn't show up right away is because we have this wind fields only toggle. So if it's on, then it'll only plot when you have winds or wind direction. If it's off, it'll plot for everything. And that's, of course, again, because we have to send you all the data, render it, and it slows down the interface a little bit. So if you don't need it, we don't throw it your way. But you can turn it on whenever you like. And so whenever you zoom out or pan around, the wind barbs draw based on your criteria. So right now we have the reveal as always, but again, if you move the slider over into the black, the reveal, if you're within the black, the wind barbs will go away. So it'll only reveal itself when you zoom in far enough. And it appears that I've locked up my browser. So Dave, thank you for your question. Wow, I can't.
Indeed. Thank you. Thanks, Dave. And John, other questions from the audience?
Sure, a real quick one. someone would like to know what is the, let me see if I can find it here. What is the URL for the site? Yeah, what is the website for this data? From Tom.
So this user interface, hey, good at caught up. So this interface, whatsup.mdl.nws.noaa.gov. That's whole story uncertainty probability.mdl.nws.noaa.gov. What's up? And that'll get you to the main plan view. So that'll get you to this page. And from there, you can get to the you can get right to the point viz interface by either clicking and grabbing it is the easiest way, or if you wanted to, this little magnifier, this magnifying glass feature allows you to type in. So if you want a DCA, you can type that in, it'll pan over to your station, and then you can click on that. So if you wanted a specific station, you know which one you want, you can grab that. I will also say that the plan view and the point visualization are API'd, so you can take this. So say you're say you have a very specific case with max temperature, you say in West Virginia per se. Say you're paying attention to the snow coming across the mountains, and you can grab this URL, send it to a partner or someone who has access to WhatsApp, and it'll take your all of your configurations. That's whatever what base map you were using, all of these, as well as the any GIS overlays. It keeps those and the opacities in the URL, so they'll get your exact view. The only thing we do not preserve is the forecast time at this moment. It's complicated technically just because of how we fetch the data, but you can very easily navigate to the valid time of your choice. And the point viz is also API'd as well.
Wonderful. We have another question from Eric Fornash. He says, excellent presentation. You may have touched on this. In regards to the threshold on the 1D viewer, would you be able to request multiple threshold criteria probabilistic output? For example, RH less than 20% and winds greater than 15 knots.
I don't see why not. We have all the data for that grid point. I don't see why we wouldn't be able to do both of those. That's a great suggestion. Thanks for letting us know. Feel free to shoot that via email to me so I don't forget it, but that's a really good idea. We should, I would think so.
And I guess one other thing, Daniel Neitfeld says, just a reminder that GSL has been enhancing the NBM 1D viewer and hosting it. It is still available on GSL site and is currently open to all.
Yes, that is true. GSL had a big hand in the development. Jeb is over there.
Yes, and we're very grateful for that and its use during COVID. Thank you very much, GSL and company. Other questions, John?
Yeah, we have, I think, one from John Dumas, who has left, but he asked, we've been using the 1D viewer in Los Angeles for a few months, and it's extremely helpful. We especially like the possibility of exceedance ability and the aviation tools. So I guess that was a comment more than a question. And then Tim Baker says, percentile or distribution information seems to be mainly available only for some fields, such as QPF, snow, temperature, etc. But there are many more fields where more percentile or full distribution data would be helpful, such as wind speeds or mixing heights, etc., which are very non-Gaussian distribution variables. Are more distribution data coming at some point? And would that all be viewable in these displays once they are available?
So I will say that one, any element that the NBM has, we can view. We're in the digital forecast services division, and the NBM's in the statistical modeling division. So of course they're MDL, but we don't directly impact which elements get made. But Jeff Craven can take that feedback. He might be on the call. I'm not looking at the attendees at the moment, but
Yes,
oh, good, Craven. There you go. But yes, so whatever elements are available, we do plan to add into all of the viewing capabilities that we have, and we look forward to adding whatever comes available.
All right, I think we've touched on all the questions.
Yes, thanks, John, and thanks, Dana. We're at the end of our time. I want to thank Dana and the MDL crew for really excellent work and a very informative presentation, demonstration. I hope that you all go back and test drive some more when the viewers avail. So it's still will be a little bit more before everyone can access the 1D viewer part, right, Dana?
Correct. Yeah. So it's still under development, but it's going to be in our next release.
And thanks to the CI/CD delivery pipeline that we have in Amazon Web Services, we can get that out there with expediency as soon as it's ready. We don't have to wait for NCO or any other organization to do that. We could do it ourselves. Good for, yay MDL, yay STI, doing the good work here. So as soon as it's ready, we'll disseminate that far and wide, and you guys can get out there and have at it. So thank you again, Dana, and thanks for the audience. I want to remind folks that coming up in the VLab Forum in February, we've got talk on Florida summer probability of precipitation climatology used to supplement the MBM by Brian Mroska. And in March, we've got Dr. Chris Balch of this Space Weather Prediction Center, SWPC, NCEP Center, talking about NOAA USGS 3D geoelectric field model. This is a really innovative technique where you're sort of bringing that space weather impacts down to Earth, and how that could impact the electric grid and so forth. So first space weather talk ever in the VLab Forum. So I think both of these should be of great interest. So tune in, and we hope to see you in February and March. If not, thanks everyone for this one, and a great inaugural VLab Forum presentation for 2021. And we'll see you in February. Thanks everyone.
Thank you everyone.
A good one.